Aileron surface. Purpose of aileron surface. The ailerons have two purposes. The ailerons supply low-speed roll control of the airplane. The flaperons and the flight spoiler have this function. Ailerons also move down to supplement the high lift system. Flaperon surfaces. The purpose of flaperon surfaces. The flaperons have a dual purpose on the 777 airplane. First flaperon supply roll control of the airplane, assisted by the ailerons and the flight spoilers. Second flaperons move down to help the high lift system during takeoff, approach and landing. Functional description of flaperons. When the flaperon moves down, a mechanical linkage pulls the drive link attachment point of the fitting up. This rotates the cuff lip door up, which supply a gap along the leading edge of the flaperon. The flaperon surface deflection limit are at the PCU internal stops. The flaperons have a maximum movement of 11 degrees trailing edge up TEU and 37 degrees trailing edge down TED for condition without loads. When there are loads, the maximum PFC and ACE command signal move the flaperon to a nominal position to 10 degrees TEU and 30 degrees TED. Spoiler and speed brake control. The spoiler help the ailerons and flaperon control airplane roll about the longitudinal axis. They also supply speed brake control to reduce lift and increase drag for descent and landing. There are 7 spoilers on each wing. The 5 outboard spoilers are forward of the outboard flap. The 2 inboard spoilers are forward of the inboard flap. Each spoiler have an assigned number from left to right of 1 through 14. Each spoiler is part of a symmetrical pair. For example, spoiler pair 4 and 11. 1 ACE and 1 hydraulic source control a pair.
Trailing edge flaps. Trailing edge flaps is during takeoff. The trailing edge flaps increase the lift of the wing. During landing, the flaps increase the lift and drag. The flaps are not used during cruise. The trailing edge flaps improve the takeoff and landing performance of the airplane. When the flaps extend, they increase the lift of the wing. They also help to decrease the airspeed during landings and approaches. The flaps are part of the high lift control system. The high lift control system electrically controls the flap with a fly-by-wire system. During takeoff, landing, the pilots use the flap lever to command the flaps to move to an extend position. During cruise, the pilots command the flaps to retract to the up position. Each wing has an inboard flap and an outboard flap. The inboard flap is double slotted and has a main flap and an aft flap. The outboard flap is single slotted and is one piece. The flap operation is the flaps operate in sequence with the slats at cruise speed and altitude. Flap extension is inhibited. The load relief function retracts the flaps to prevent structural damage to the flaps at high air speeds. The flaps are monitored for skew or asymmetry. When the system detects a skew or asymmetry, the flap drive shuts down. Leading edge slats and Kruger flaps. During takeoff and landing, the leading edge slats and Kruger flaps increase the lift of the wing. These surfaces are not used during cruise. The leading edge slats improve the takeoff and landing performance of the airplane. When the slats extend, they increase the lift of the wing. They also increase the angle of attack at which the wing stalls. The slats are part of the high lift control system. The high lift control system electrically controls the slats with a fly-by-wire system. During takeoff and landing, The pilots use the flap lever to command the slats to extend to the seal or gap positions. After takeoff, the pilots use the flap lever to command the slats to retract to the up position. Each wing has an inboard slat, a Kruger flap, and 6 outboard slats. The Kruger flaps are made of aluminium skins and aluminium castings. The width of the Kruger flaps is approximately 30 inches and it weighs approximately 90 pounds. The Kruger flap has two positions, retracted, and extended. It moves to the extended position when the slats are in the seal or gap position. It moves to the retracted position when the slats are at the up position. The operation of the slat. The slats operate in sequence with the flaps. At cruise speed and altitude, slat extension is inhibited. During secondary mode operation, the load relief function retracts the slats at high airspeed. The auto slat function extends the slats to improve the airplane stall performance near stall conditions. The slats are monitored for skew or asymmetry. When there is a skew or symmetry, the slat drive shuts down. High lift control system. The high lift control system uses a fly-by-wire control system with digital electronic equipment. It receives commands from the flight crew and causes the flaps and slats to move. Operation of the high lift control system increases the wing lift so that the aeroplane can take off and land at lower speed and higher weight. The high lift devices operated by the high lift control system are 7 leading edge slats on each wing, 1 Kruger flap on each wing, 1 single slotted outboard flap on each wing, 1 double slotted inboard flap on each wing. Operation of the high lift control system also causes the ailerons and the flaperons to move. They drop on both wings when the high lift devices extend. The purpose of the high lift control system improves the take-off and landing performance of the airplane. The high lift control system includes the trailing edge flaps and leading edge slats.
Hello, I'm going to explain about the rudder control. The rudder controls the flight attitude of the airplane about the vertical axis. The rudder hinges on the rear spar of the vertical stabilizer. A rudder tap increases the effect on the rudder. The rudder tap moves further in the same direction as the rudder. The rudder is responsible for the yaw control. The pilots make a manual yaw correction with the rudder pedals. The autopilot does not control the rudder during most phases of flight. When the autopilot is engaged during the approach and landing phases of flight, the auto land function commands the rudder. The backdrive actuators then backdrive the rudder pedals. The rudder assembly purpose is to supply the control of the airplane in the yaw direction. The rudder tap pivots on the lower trailing edge of the rudder. The rudder is a lightweight composite material structure. The skin is reinforced graphite bonded to a core of Nomex honeycomb. The rudder PCUs have internal stops that limit the rudder surface deflection. The rudder has a maximum movement of 27 degrees in both directions at low airspeed under no load conditions. Under loads, the maximum PFCs and ACEs command signals move the rudder to a nominal position of 25 degrees in both directions at low airspeed. The elevators supply short-term correction of the pitch attitude of the airplane. This movement is around the lateral axis of the airplane. There is one elevator panel on each side of the aft fuselage. Hinges attached to the elevator to the rear spar of the horizontal stabilizer. 2 hydraulic power units move each elevator panel. The elevator is responsible for the pitch control. The pilots manually command pitch correction with forward and aft movement of the control column. When engaged, the autopilot automatically commands the elevators. During autopilot operation, actuators backdrive the control columns. The purpose of elevator assembly is to supply short-term pitch control of the airplane. The elevators are lightweight composite material structures. The skin is reinforced with graphite bonded to a core of Nomex honeycomb. The overall dimensions are approximately 70 inches by 403 inches. Each elevator panel weighs approximately 337 pounds. The elevator attaches to the stabilizer rear spar with 7 hinges. There are 4 PCU attached fittings on each elevator. Jumpers and static discharges supply electrostatic protection. The elevator surface deflection limits are at the PCU internal stops. The elevators have a maximum movement of 33 degrees trailing edge up and 27 degrees trailing edge down under no load conditions. Under load condition, the maximum PFC and ACE commence signals move the elevators to a nominal position between 30 degrees TEU and 25 degrees TED. Okay, next we're going to talk about the pedal assembly. The purpose of this pedal assembly is to get the pilot commands and transmit them to the rudder control system. The physical description is the rudder pedals are conventional in design. Each pilot has 2 pedals. The pedals of each pair move in opposite direction of each other. Now the functional. When the pilot moves the rudder pedals arms pivot on the rudder pedals pivot axis. Control rods transmit the movement of the rudder pedals arm to the jack shaft assemblies and the yaw control system. The pilot uses the rudder pedals to operate the wheel brakes. The pedals then rotate on their upper pivot axis. The purpose of control column is to command the pitch control. The control column is a one-piece aluminum casting. It is approximately 36 inches long. The control column extends down through the flight deck floor and attaches to the top tube with 4 bolts. The 2 control columns are on the flight deck. Fore and aft movement of the control column operates the pitch control mechanism below the flight deck. The horizontal stabilizer supplies a long-term correction of the pitch attitude of the airplane. This movement is around the lateral axis of the airplane. Stabilizer control. The elevator on-float function automatically sets the position of the stabilizer during manual flight or in auto flight. In this mode, the PFCs monitor elevator deflection and transfer pitch changes to the stabilizer. Once the stabilizer goes in its commanded position, the elevator moves to neutral. The pilots command the stabilizer to move with either the pitch trim switches on the control wheels or the alternate pitch trim levers on the control stand. The pilots stop unwanted stabilizer movement with the stabilizer cutout switches on the aisle stand. The operation of stabilizers. 2 hydraulic motors with 2 speeds move the horizontal stabilizer through a jack screw mechanism. 4 rates of horizontal stabilizer movements are available.
The purpose of Kruger flap are lift enhancement device that may be fitted to the leading edge of an aircraft wings. The location of Kruger flap is in the fixed leading edge of the wing between the engine and the inboard slab. Remove the access panel on the upper side of the wing to get access. The functional of Kruger flap is attached to the rotary actuator. As the rotary actuator rotates, the links in the Kruger flap mechanism move. This link forces the Kruger flap to extend or retract. As the slab extends to the seal position, the Kruger flap moves to the extend position. As the slab extends to the gap position, the geometry of the links in the Kruger flap mechanism prevents more movement of the Kruger flap. The Kruger flap mechanism moves the Kruger flap. The benefit of the fly-by-wire system for Boeing 777. The fly-by-wire design of the
flight control permits. First, a more efficient structure design. Second, increased fuel economy. Third, a smaller vertical fin. Next, a smaller horizontal stabilizer. The second one is reduce weight, and the lastly, improve control and protection.